Hello everybody. This video is the first part of the linear functions and models, that is section 2.5 of your book. In this part we will learn about what are linear functions and how to identify linear functions, what is its general equation, and how to graph linear function, and also what is the relationship between slope and linear function. So with all this, I have actually introduced linear functions when we discussed types of functions like root functions, power functions, etc. in previous videos. Then I had defined linear functions to be f of x of the form f of x is equal to ax plus b, where a represents slope and b represents y-intercept. So to put the things mathematically in words, so we can define linear functions. I shall abbreviate linear functions as LF. That is not a standard abbreviation, that is just my abbreviation to avoid more writing. So a linear function, I should have used LF. Okay, is a function of the form f of x is equal to ax plus b, and graphically the graph of linear function, the graph of LF is a line. It is basically a straight line with the slope a and y-intercept b. So slope a and y-intercept b. So if you are given a function and if you are asked to find out whether it is a linear function or not, what you have to do is you have to reduce the function to a simple form and check whether it matches to the standard form, that is this form f of x is equal to ax plus b. If it matches to the standard form, that would definitely be a linear function. If not, it is not a linear function. So we will do certain problems of identifying whether a given function is linear or not. So this is actually number 12 in your book. So f of x is equal to 2x minus 3 divided by x. So this given function can be written as f of x is equal to 2 minus 3 divided by x. So you can write the function as this, and you can observe that this doesn't match to the standard form f of x is equal to ax plus b, because the power of x in the standard form is 1, but in the given equation the power of x is -1. So it is not, the given function is not a linear function. The conclusion goes like this: it is not a linear function. So we will do something that is like really positive, like we will check whether a function is linear or not, and you get it to be linear. So that is number 14 in your book. So f of x is equal to 1 over 2 times 3x minus 1. So here you can observe that you can write f of x as distributing 1 over 2 to the terms inside the braces. You will get 3 by 2 divided by x minus 1 over 2. So this is definitely of the form f of x is equal to ax plus b, where a is 3 over 2 and b is -1 over 2. Therefore the given function is a linear function. So this is how we identify or determine whether the given function is linear or not. So next we shall see what is how to graph a linear function. So you know how to graph functions, right? You take arbitrary x values and find out their functional values, and with this problem we will see how exactly does a linear function look like how is it really a straight line or something. So we shall make table of values and sketch its graph and find out the slope of the graph as well. So now this is now problem number So the concept that we are learning is graphing linear functions. So this is problem number 16 in your book. So g of x is equal to 4 minus 2x is the given function. So how do you excuse me, how do you plot the graph of the function? So you take x and its corresponding functional values. G of x is equal to 4 minus 2x. I will choose these arbitrary values, -2, -3. So and their corresponding functional values would be, when x is 0, g of x is 4. When x is 1, g of x is 2. When x is 2, g of x is 0. When x is 3, 4 minus 6 would be -2. When x is 4, 4 minus 8 would be -4. And when x is -2, 4 plus 2 would be 6. When x is -1, yeah, it would be, g of x would be 6. And when x is -2, 4 plus 4 is 8. And when x is -3, 4 plus 6 is 10. So now we have to plot this. So I need a coordinate plane. Yeah, here is my coordinate plane. We will plot this. This is our x-axis and this is our y-axis. So 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5 and 1 2 3 4 5. So these are negative values, but I think positive side I need 10 values. So I have just 5 6 7 8 9 10. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, and 1 2 3 4 5 6, -1 -2 -3 -4 -5. Okay, now let us start plotting the points. Okay, 0 comma 4 is here. 1 comma 2 is here. 2 comma 0 is here. Sorry, my 1 is not there. Yes. Okay, so it is here. Okay, so 2 comma 0 is plotted right. 3 comma -2 is here. Then 4 comma -4 is 4 comma -4 is here. And -1 comma 6, -1 comma 6 is here. Then -2 comma 8, -2 comma 8 is here. -3 comma 10, -3 comma 10 is here. So you can see the points are collinear. So if I draw a straight line, that means if I connect the points, let's see whether it looks like a straight line or not. Yes, it does. So this is the graph of the given function. So we are also asked to find out the slope of the graph. So slope of the point is same as average rate of the function. So when we compare the given equation to the standard form of the linear equation, we can see that when the standard form is this, ax plus b. So where I said that a represents slope and b represents y-intercept. So if we compare g of x with f of x, so our a is -2. So if we calculate the average rate of change of g of x for two certain arbitrary input values that is in the table, do we get -2? Let us check that. We shall calculate the average rate of change of g of x for in between 2 and 4. So then that would be average rate of change of g is nothing but g of 4 minus g of 2 divided by 4 minus 2. So g of 4 is nothing but negative 4, g of 2 is nothing but 0, so that divided by 2 would be negative 4 over 2, that is nothing but negative 2. So this value definitely matches our a value that we got after comparing the given equation with the standard form. Therefore, what I said, the slope is nothing but the average rate of change of a function, is true. So you may ask, why do you have to name those two differently? So the main difference between slope and average rate of change is the viewpoint. That is, when you are asked to find out average rate of change of a function, you focus mostly on two different output values with respect to two different input values. But when you see slope, you think in terms of the inclination of the graph, or the amount of inclination of the graph with respect to x-axis. So that is like, if I say what I said now in terms of real life situation, if you say that a tank is getting filled with water, and you describe how the water is getting filled inside the tank, you can say that it is like 2 liters or 3 liters per minute. So you may say that it is getting filled at 2 liters to 3 liters per minute, or you can also say in terms of the level of the water with respect to the brim of the tank, right? So the viewpoint is the major change in it. Apart from that, the value and the formula, and also the value that it gives are one and the same, because the formula is one and the same for slope as well as the average rate of change of a function. Okay, so that's how let us define now slope and rate of change. So our slope is for LF, that is linear function, f of x is equal to ax plus b. The slope of the graph of f, the slope of the graph of f, and rate of change of f are both equal. So that is what I stated or explained to you as I solved the previous problem. Equal to a, that is the coefficient of x. So mathematically, writing it as an equation, a is nothing but equal to slope of f, that is equal to, slope of graph of f, correct? So slope of graph of f, that is equal to rate of change of f with respect to any two arbitrary input values. Okay, so we will look at some word problems, or before that, okay, before that we will find a linear function. I won't sketch the graph as given in the exercise, but I will find the slope of the graph and find the rate of change of the function. So this is exercise number 24. So you are given a of r is equal to negative 2 over 3 r minus 1. So alright, this is the given function. You are asked to find out slope and rate of change. So when you compare for the slope, when you compare it with the standard equation of the linear function, you can see this matches to the standard equation of the linear function. So that is f of x is equal to ax plus b. So what is the coefficient of x in this case, and what is the coefficient of r in this case? So r, that would be our a. So a is equal to negative 2 over 3. So that is the slope of the graph of capital A, correct? So that is negative 2 over 3. So we shall take some two arbitrary input values and find out the functional values of it and find difference quotient, so that to just check whether we get the same slope when we do it in the using the formula of average rate of change. We do get it because we already checked it in the previous problem. I'm just doing it again. Okay, average rate of change of the function A. So for that I need okay, I will take some A of 2 minus A of 0 divided by 2 minus 0. Okay, so that would give us A of 2 would be negative 2 over 3 times 2 minus 1 plus 2 over 3, that is 0, plus 1. So divided by 2. So this would give us negative 4 over 3 minus 1 plus 1 will get cancelled, and this term is 0. So you are just left with negative 4 over 3 times 1 over 2. So if you cancel this, so you will get negative 2 over 3. So what we stated above, that is slope to be equal to average rate of change of a function, is true. So that is what we checked here. So I will be giving you quiz questions in part 2 of the video, or that I will be doing explaining the making and solving linear equations. So that would be part 2 of this section. I will be giving quiz questions in that, and there are no quiz questions in this video. Okay, there is another problem, that is 28. This is there is a verbal description of the linear function. So you have to express it in a mathematical form, or you have to express in the form of f of x is equal to ax plus b. So the verbal description goes like this. The linear function g has a rate of change negative 12 and initial value 100. So you may be confused, like you know that rate of change is equal to slope, so a value is nothing but negative 12. That is very clear and straightforward from the question. But when you look at the other part of the question, that is initial value to be equal to 100, so you may be confused, what is this 100? So what do we have to do with this? So the very basic or layman's instinct is that, okay, there is another unknown, that is b, so that has to be 100. But why is it named initial value? So initial value for any function would be when x is equal to 0, right? So f of x is equal to ax plus b when x is 0. So this term is 0, that is ax will be 0, and you are just left with b. So you are given f of 0 to be 100. So that is nothing but the v value. So don't get confused if you are given, if the verbal description says initial value or y-intercept. Okay, it is one and the same. That's why our b value by the verbal description would be 100. So substituting the unknowns inside the general form, f of x is equal to ax, we get f of x, g of x. The function is named as g of x. Okay, so g of x is equal to a is negative 12x plus 100. So this is the answer. This is how you convert verbal description into mathematical equation. Okay, moving further, we will solve a word problem. So this is number 40 in your book. This is something, a problem related to copper mining. I will just read out the problem. I won't write stuff, but I will write the data that I get from the problem. So that would be, the statement goes like this. The amount of copper ore produced from a copper mine in Arizona is modeled by the function f of x is equal to 200 plus 32x. where x is the number of years, since x is equal to number of years since 2005 to since 2005. Okay, and f of x is measured in tons, is measured in 1000 tons, is measured in thousands of tons. Okay, so what are we asked to find? We are asked to sketch the graph of the function, b what is the slope of the graph, and c at what rate is the function of ore produced changing. So you can very well do I have to sketch the graph? It is very simple, like 200 plus 32x. So change the value of x from 2005, start from 2005, 2005, 2006 and so on, and find out what would be the value of f of x, corresponding value. Use a calculator. I will find out two values so that I can use it for my finding out the average change. So for 2005 it would be 200 plus 32 times 2005. So that would give me that would give me 32 times 2005 is 64,160 plus 200 is 64360. Okay, and 2008 I will do that. You can calculate the rest of the table of values and plot the graph. That is very simple. I have done many examples of sketching the graphs. So 200 plus 32 times 2008, so that would give us 2008 times 32 would be 64256 plus 200, so that would be 64456. So that is 64456. So I will use these two values to find out the average rate of change of the function. And slope, you can find it out using the comparing the given equation to the general form. So if we compare the given equation to the general form, it would be f of x is equal to ax plus b. So when we compare it, our b value is 200 and our a value is 32. So a is equal to 32. So this is nothing but the slope. Correct? So then using the average rate of change formula, so we have f of 2008 minus f of 2005 divided by 2008 minus 2005. So that would give us, this is nothing but average rate of change of f. Yeah, so that would be equal to f of 2008 is 64456 minus 64360 divided by 3. Correct? That would give us a 4 I'm sorry. The numerator reduces to 6. 5 minus 6 is not possible, so I will have to take a carryover. So that would be 96. So the rest is 0. Okay, 96 over 3. So when I divide this, I will be getting 32. So definitely it matches to the slope value, that is a value. And again we are right by saying that average rate of change is same as the slope. So I will give a collective quiz questions of all the section. This is just a part 1 of the section. I will give collective quiz questions in part 2 where we will learn about making, and that is like formulating the linear function, as well as modeling it, as well as using, like how do we use linear functions and whatever we learned till now. Okay, see you soon with more problems and more solutions and quiz questions as well. Thank you.